Yeah, tell me what are those equations of motion? Yeah. Yeah, V is equal to U plus H. Okay, you don't worry. I will quickly help you with the revision. And today we will be basically focusing on force topic. We will start with a new topic as well in today's class. And before I start with the new topic, I will help you with this revision, quick revision. And from here you can just get help. Uh, this is a topic that you can see here. Measuring and graphing speed, difference between speed and velocity. So far we have understood that what are difference between distance and displacement, and later on we covered what is difference between speed and velocity as well, and we have drawn graph as well. Okay, all right, and we just understood what are different state of body, that may be rest and motion. In rest, body doesn't change its position with respect to time. In motion, body changes its position, and later on we covered the concept of different parameters that we get whenever object comes in rest. Whenever there is motion, we consider distance, displacement. Further, we consider speed, velocity. Further, we have acceleration. When we consider quantities, there are two kind of quantities: physical and non-physical. Physical quantities are measurable, where non-physical quantities are non-measurable. Measurable means you have some instrument by using which you can measure them. Like a speedometer is there to measure speed, odometer is there to measure distance, ammeter is there to measure current, voltmeter is there to measure potential difference. Then later on you will study what is ammeter, what is voltmeter, what is electric circuit. Actually, we use ammeter and voltmeter in electric circuit. One device is there, galvanometer. They all are devices that we use to measure, and the parameters that we are measuring using them are known as physical quantities because they are measurable. Further, non-physical quantities are those which are non-measurable, like our emotions, maybe love, sorrow, happiness. They all are non-measurable, and that is why they are non-physical quantities. Later on, we consider the division of these physical quantities, and we divide them under scalar and vector. Scalars has both magnitude and scalar has only magnitude but no direction, and vector has both magnitude and fixed direction is also there with vector quantities. We just covered and we just came to know that mass, energy, distance, speed, they all are having only magnitude. That is why they are scalar. Whereas displacement, force, velocities, acceleration, even they are actually vector quantities because they have a fixed direction besides their magnitude. Then we categorize distance and displacement. Can you tell me what are differences in distance and displacement? I want you to explain this topic. What is distance? What is displacement? Just categorize them under some points that I have presented. Tell me, Sanket, what are differences in distance and displacement? Exactly. Uh, yeah, you categorize it. It's nice. You just told me that distance is total path and displacement is the shortest path. Even you can use one point that is SI unit. Both have the SI unit meter. You can use the third point. The distance is a scalar and displacement is vector. Okay, then we have solved all these questions. I think you can answer all these. Okay, this is a last. This is a last part that I summarized quickly, and today as well I will help you with these 9, 10 points. Okay, and I just want you all guys to just write down all these things. You all write down all these things. These 10 points are sufficient to cover this entire chapter motion. Okay, I'm going to help you with all these 10 points once again. All right, Sanket, and you all see here. What is motion? We all know it is one of the state of body. What is motion? Can you tell me what is motion? The state of body. And which particular state? In which a body moves. A body changes position with respect to time. You will define like this: a state of body in which it changes its position with respect to time. In which it changes its position with respect to time. WRT means with respect to time. Okay. And here, whenever there is motion, we have distance, we have displacement, we have speed, we have velocity, we have average speed, we have average velocity, we have acceleration, and we also have conversion, we have equation of motion. They all are there whenever you have motion. What are these 10 points? We are quickly going to cover all of them, and I want you all to note it down. I want you all to remember this and write once again, because writing helps us to recall things, remember things, and even it helps to grab things. That is why I just force you all, ask you all to write it. Okay, what is distance? It is total path. What is unit? Meter. What is its nature? It is scalar, has only magnitude, no direction. What is displacement? It is the shortest path. What is SI unit? Meter is the SI unit. What is its nature? It is vector quantity. It has both magnitude and direction. That is why I am saying it is a vector quantity. When I say direction, that means fixed direction is there with that quantity. What is speed? It is simply the ratio of distance over time, and it is simply rate of change of distance, you can call like that. Its unit is meter per second, and it is a scalar quantity. What is velocity? It is simply the rate of change of displacement. That means it is displacement over time. Its SI unit is meter per second, and it is a vector quantity. What is average speed? Average speed for anything, for any motion, is simply total distance over total time. And this is a special case of average speed. What is the special case of average speed? Let's say you are traveling two distances of same distance. I'm saying you are traveling two same distances with two different velocities. Then you can use this formula, twice v1 v2 over v1 plus v2. I'm helping with an example. Let's say you have example for this. Let's say you are traveling a distance of 10 km with speed of 10 meter per second. Then you are traveling another 10 km with the speed of 20 meter per second. If now someone asks you to figure out average speed, what will you do? In order to figure out average speed, you will use the formula twice v1 v2 over v1 plus v2. Because distance is same, you can use this formula. What is v1? It is simply 10. What is v2? It is simply 20. What is v1 plus v2? It is simply 10 plus 20. In this way, you can just figure out your answer. Twice times 10 times 20, and here it is 30. And the answer is coming out to be 40 over 3 meter per second. Now is it clear where we need to use this formula? This is a special case of average speed that is used when you travel same distances with two different speeds. Got it? Got it? What is 8th point? Let me know whether you are okay with this 8th point or not. This 8th point is just the improvement version or a special version of 7th point. Now what is average velocity? If you are given with a condition that you start with initial velocity u and you reaches a final velocity v in time t, and you also cover a distance obviously, in such a case you can find out average velocity by just adding these two velocities and dividing it by 2. That means you take average of them and you will find out the average velocity. And acceleration is simply the rate of change of velocity. That is why in this particular scenario, you will consider the difference of velocities, that is v minus u, and you will divide it by time. You will get acceleration. And from here itself, you will also able to derive your first equation of motion. Because acceleration a is v minus u over t. That means at is v minus u. That means u plus at is v. And this is your first equation of motion. And from here you derived it. Its unit is meter per second squared. And similarly we have acceleration due to gravity, that is acceleration that we get when there is an attraction between two objects, or attraction of earth is there, the force is there, and that force is actually gravitational force, and in that scenario we get this acceleration, which is called acceleration due to gravity. If you want to convert, that means if you want to convert kilometer per hour into meter per second, or you want to convert meter per second into kilometer per hour, what we need to do that? If you want to convert, or if you are just converting kilometer per hour to meter per second, you multiply by 5 over 18. And if you convert meter per second to kilometer per hour, you multiply by 18 over 5. And then we have equation of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to twice at. I've also introduced the fact here that gravitation or acceleration due to gravitation on moon is 1/6 of that of the earth. And then we solve these questions, derive the equation of motion, and we just solve these questions. That I think you must be okay. Okay, the 7th question is there in front of you. We will solve few questions today, and then we will start with a new term. Okay, read the question and tell me the answer. Thank you. And you all can comment the answer. Yeah, Sanket. Yeah, tell me the answer to this. The question is, an object moves, but what is this? It is saying uniform positive acceleration. Yeah. Its velocity time graph will be. We are supposed to draw VT graph, velocity and time graph. What does it mean? It simply means that velocity is there in y-axis, and time is there in x-axis. As you will keep on increasing the time, what will happen with velocity? We need to figure out this. The uniform positive acceleration, it says. Acceleration is uniform. Uniform means acceleration remains same. Uniform means acceleration is same, but it is positive. if uniform acceleration is there, there must be increase in velocity. And if velocity is increasing, that means it is like this. When there is an acceleration, the graph goes like this. If there is no acceleration, that means no change in velocity, graph goes like this. It indicates zero acceleration, but it indicates some positive acceleration. That means it is your answer. That means which option is going to be the correct option? A straight line parallel to time axis? It's not so. It is for acceleration zero graph. It's not true. The first one is not true. A straight line inclined at an obtuse angle to time axis. Is it obtuse angle or acute angle? What do you say? Is it obtuse or acute? Which angle is acute? If an angle is between, if an angle is between 0 and 90, it is acute. If an angle is between 90 to 180, it is obtuse. That means if an angle is between 90 to 180, it is obtuse. If an angle is exactly 90, it is right angle. If it is exactly 180, it is a straight angle. If it is between 180 and 360, it is reflex angle. Do you think the option B is correct? It's not correct because this angle is not obtuse, it is acute. A straight line inclined at an acute angle with time axis, it is correct actually. Got it why? You got it why? Because we have discussed this curve in previous class. See here, rectilinear motion, if this motion is there, it is xt graph, position time graph. The velocity is actually there. Uniform velocity is there. Uniform motion it is. And VT graph, in case of VT graph, the graph goes like this that I have just presented here. This is the graph in which motion is having no acceleration. That means uniform velocity. Velocity is fixed. Here it is. Velocity is increasing with a pattern so that acceleration remains same, and that acceleration is positive. You got it? Now the question number 8 is here. The maximum speed of a train is 90 km per hour. It takes 10 hours to cover distance of 500 km. Find the ratio of its average speed to maximum speed. Time is given, total distance is given. Total distance is given to be 500 km. Time taken to cover this distance is given to be 10 hours. Maximum speed attained is given to be 90 km per hour. This is the condition. We all know the average speed is nothing but total distance over total time. This is the average speed. And here the total distance is 500, total time is 10 hours. That is why the average speed is coming out to be 50 km per hour. This is actual average speed that you get. 50 km per hour is the average speed. And they just ask you to figure out ratio of average speed to maximum speed, and that is coming out to be 50 over 90. That is 5:9. because here we got the average speed, that is simply total distance over total time, that is coming out to be 50 kilometer per hour. We are given with the maximum speed, that is 90 kilometer per hour. Now if we want the average of these two, that means we want the average of we want the ratio of average velocity and max velocity. That means we need to figure out the ratio of 50 and 90. That is coming out to be 5:9. Is it clear to you? Very good, very good. Okay, now next question, ninth question for you. Very interesting question. A car starts from rest. What does it mean? If it starts from rest, what does it mean? U is equal to how much? U is equal to 0. Okay. And it attained the final velocity of 50 kilometer per hour. We can convert it into meter per second. We just need to divide, multiply by 5/18. That's coming out to be 15 meter per second. We now got the initial velocity, final velocity, and time taken is 2 seconds. Can you tell me what is acceleration? Which formula do you use? V minus u over t. And if I ask you to figure out your answer, you can just put the value of v equal to 15, u equal to 0, t equal to 2, that is 15 over 2, that is 7.5 meter per second square. Distance traveled by car. Can you tell me distance traveled by car? How can you find out distance? Which equation do you remember? The first equation is v is equal to u plus at. Here distance is not involved. What is the second equation? It is s is equal to ut plus half at square. Here distance is involved. Do you know u? Do you know t? Yes, we know u, we know 2t. We can find out distance with this formula. U is 0, t is something, plus half, a is, we have determined a, 15 over 2. T square is simply 2 square. And now this is coming out to be 2, 0 times 2 is 0. And here we can cancel out this, we can cancel out this. We got 15 meter as our distance traveled. Is it fine? Alright, okay. It's 15 meters. Now question number 10th is here for you, and I think you can answer this question. An object dropped from a cliff. It's like that. There is a cliff, and from where this is a ground, let's say. You have just dropped the object from this cliff and it just fall down to ground. This is the scenario. An object dropped from a cliff falls with a constant acceleration. The acceleration here is constant. It is called acceleration due to gravity. Find its speed 5 seconds after it was dropped. Time is given. It's to be 5 seconds. Okay, initially it was 0 velocity that we had. Because we are dropping it, we are not throwing it. And what speed will it gain in 5 seconds, we need to figure out. We know the formula, v is equal to u plus at. If we use this formula, u is equal to 0 here, a is equal to 10 here, t is equal to 5 here, we will gain the speed of 50 meter per second in this 5 second time duration. Is it clear for you? Very good. 50 meter per second is our answer. Okay, next question for you here. I think you can answer the question number 11. It's again the same scenario. The scenario is like this. A ball is thrown upward, but right now the condition is here. You have just thrown this ball upward. From the ground, you have just thrown this ball upward. And now it goes to the height of 100 meters. Now if you calculate the height, it is coming out to be 100 meters. And comes down. And it has just reached the height and also comes down. What is the net displacement? As it comes down at the same place, net displacement is 0. What is net distance? It's 200. Very good. It's easy, rather easy. It was easy. And now I am leaving all these questions up to you. I think you can solve them. Okay, if you want any of them to be solved here, you can just ask, because I have already presented them earlier as your homework, and I think you can answer them all. Here, if you have velocity time graph and you are supposed to find out distance, you can just take the area, because area gives you the displacement. And here, all these are so easy. This is based on your concept of circular motion. You need to use the formula distance over time, that is 2 pi r over capital T, and here 2 pi r, 2 pi and r is here, and capital T is 24. If you just solve this and put all these values, you will get 11.05. In this way you can find out this. This is going to be your escape velocity. Yeah, revolve around the earth it is. Okay, alright. Then we have this last question. I want you to appear. See here and tell me the answer. The velocity time graph shows the motion of a cyclist. Find its acceleration, its velocity, the distance covered by the cyclist in 15 seconds. Its velocity is constant actually. You just need to see the graph and tell everything. The graph tells everything. What is acceleration if velocity is constant? If velocity is constant, initial velocity and final velocity are same. This v minus u over t is acceleration. And if velocity is same here, that means initially the velocity is, final velocity is also 20, initial velocity is also 20, and time may be anything. Let's say you are considering it in 10 seconds. 0 over anything is going to be 0. That means acceleration is 0 actually. I have already told this graph earlier, if you remember. Here I have mentioned this. Here I have mentioned this. Acceleration 0 means Vt graph is going to be parallel to time axis. And that happens here as well. That is why I am saying so that acceleration is 0. Its velocity. Its velocity is here. Velocity remains same throughout. It is 20 meter per second throughout. Everywhere it is 20 meter per second. Time passed to 5 seconds, it is 20 meter per second. Time passed to 10 seconds, it is 20 meter per second. Time passed to 15, it is 20 meter per second. Time passed to 20, but it is 20 meter per second. Time passed to 25, but it is 20 meter per second. It doesn't depend upon time, rather it is constant. The distance covered by the cyclist in 15 seconds. What is distance covered by the cyclist in 15 seconds? Velocity is constant. It doesn't mean it doesn't travel. It is traveling. The distance is there. Can you tell me what is distance? Sanket, I want you to answer this. The distance covered by the cyclist. Yeah, distance is actually area under Vt graph. They want you to tell me distance traveled in 15 seconds, this much. You will find out area under Vt graph. This area you need to figure out. This area you need to figure out. Can you tell me this area? What will be this area? Area under Vt graph is your displacement or distance. And here if you find out this area, it is coming out to be length into breadth because it is rectangle. What is length here? 5, 5, 10, 5, 15. What is breadth here? Breadth is 20. That means length, distance covered is 300 meter. Got it? Got it or not? Tell me that. You can simply tell that time is 15 and velocity is 20. You can also call like this: time is 15, velocity is 20, and we all know speed is equal to distance or upon time. That means distance is equal to speed into time. Speed is 20, time is 15. It is simply 300. You can even answer in this way, or you can just remember that distance or displacement here is area under VT. Both concepts are quite important here. Got it? I think I have covered everything under this topic, motion, that is as per your syllabus. And still, if you have any doubt anywhere at any stand, if you have any question that is there where you face any difficulty, you can just ask. Sanket, is there any doubt, any point that you want me to explain, or do you have any specific question that you want me to cover here? You can just ask. You are good at it. Okay, all right. We have completed this chapter, motion, so far. Now it's our turn to consider the new topic, that is force and laws of motion. You can put the heading. It is force and laws of motion. It's force and laws of motion. Force and laws of motion, a new chapter I'm starting with today. What do you understand? What do you think that force is? How can you define a force? Because this is a topic that, this is a scenario, this is a concept that we are using in our daily life. What do you think force is? Tell me, Sanket. What do you think the force is? Yeah, exactly. Force is actually push or pull of an object. If you consider force as your topic here, you can just define, or you can just tell that force is a push or pull of an object. Okay, force is simply push or pull of an object. Exactly, you are correct here. Whenever you push an object, whenever you push means you are just applying force in forward direction. Pull means you are just applying force towards you. Towards you, you are applying force. Okay, let's say I'm applying force like this. It is push. If I'm if you are just pulling a rope, maybe an example. You can pull a rope. Whenever you push something, whenever you pull something, you are actually applying force. That is why pull or push of an object are said to be force. Okay, this is a definition that that you just see here. Push or pull of an object is known as a force. Okay, all right. Yeah. After the definition of force, I have just presented an example that help you to understand how do you pull and how do you push. If there is a block, maybe a wooden block that you have. Now, if you are just applying force in forward direction, that means you are pushing this. If you are just applying the force in towards you, you just remember you are applying the pull force here. If you are squeezing the diamond, you are actually applying force. That means a force can deform the shape as well. Now there comes what are different properties of force. Can you tell me what are properties of force? What can a force do? Yeah, tell me properties of force. Yeah, I want you to tell me different properties of force now. Yeah, forces may be contact or non-contact. Maybe there is a contact or maybe there is not contact. And next thing is I want you to tell me what can a force do? If I ask you to tell me properties of force, that means I want you to answer that what can a force do? Properties of force. A force can move a stationary object. If you are pulling something or pushing something, maybe block is in its stationary position. Earlier it was stationary, but as you applied the force, it started moving. That means what can a force do? Move a stationary object. This is first property. What is the next property of force? Exactly, may change the shape of an object. Can you tell me an example in which you change the shape of an object by applying force? Yeah, one of the very famous example is the of the lemon. If you squeeze lemon, what will happen? You are deforming its shape. Or further, it can change the speed. Like friction is a force that reduces the speed. Similarly, what is next property that you think? It can change direction. It can also change direction of any object, any body. It is also one of the property of force. What else can a force do? It can change shape, size. I have already presented that. Okay, alright, they all are properties. Now there comes different types of the force. What are different types that you know, that you remember? Yeah, there may be magnetic force. There may be friction force. Yeah, alright. Very good, you remember good. Okay, alright. There may be gravitational force, you told me. Force. Gravitational force, you just told me. Then you have what you said? Frictional force, you said. Yeah, air resistant, maybe that is a frictional force. And what else? Magnetic force may be there. Magnetic. Yeah, the main applied force may be there, exactly. What else? Then applied force is there. Buoyant force is there. When do you consider buoyant force? What is buoyant force? What is buoyant force? Let's say you are there, you are just putting some objects in a bucket full of water. The force that uplifts that object, let's say you are trying to put a volleyball inside your bucket full of water, what will happen? You will feel a force that is applied from downward direction. That is upward force you will feel. That is actually buoyant force. Got that? Then there is a tension force. What is tension force? You know the tension force? Let's say one of your friend, is trying to just pull this, and you also trying to pull this. What force are you applying here when you are trying to pull this? When you are trying to pull this, that means you are applying a tension force. There is a tension force. Let's say there is a rope here, and maybe someone try to climb here. Maybe a monkey is try to climb here. Which type of force is here? The force that you see here is tension force. We call this force to be a tension force. That means there may be gravitational force, the force that earth apply on any object, frictional force, force between two surfaces, or force that the earth's surface apply with any other object that slide on it or move on it, magnetic force, force that is there between two magnets or between poles of those magnets. Buoyant force, a force that uplifts an object when it is put on a bucket full of water. Tension force, a force that you feel uh, when you just try to climb using a rope. All these are different forces that we come across. Understood it? And this force has always a specific direction. That is why this force is always a vector quantity. This force is always a vector quantity because it has always a fixed direction. Is it clear up to this? The first thing is force is simply push or pull of an object. It can change the speed of an object. It can change direction of an object. What are different types? It may be gravitational, may be frictional. When do we have gravitational force? Between two planets it may be there. What is frictional force? On surface it is always there. What is magnetic force? It exists there with magnets. What is buoyant force? I've already told, when you put an object in a bucket full of water, you apply there is a upward force that you feel, that is buoyant force, or you also call it simply upward force, you can say, buoyant force you can say, buoyancy you can say. Upthrust, you can use the word upthrust. Then we have tension force, when a person climb using rope, or when a monkey climb using rope, there is a tension force. These are different forces that we may have. Some of them may be contact, some of them may be contactless. A touch or contact is required to do most of our everyday activities. Example, lifting, pulling, kicking, pushing, they all are actually contact force. When you pull something, when you lift something, when you kick something, when you push something. Sorry, I'm very sorry. All these are example of pushing, kicking, pulling and lifting. All they are example of contact forces. Then there may be muscular force, that you lift an object, that is type of contact force. Under non-contact force you have gravitational force, you have electrostatic force between two charged particles, magnetic force, they are contactless force. Got it? Then there may be nuclear forces are also there. A lot of forces exist. Okay, are you okay up to this? Is it okay up to this? You understood what are contact force and what are non-contact force? Okay, I want you to tell and summarize everything that I have just explained so far. Yeah. Yeah. All right. Yeah, just explain everything in brief. Yeah, you start with the definition of force and just cover everything in 2 minutes. Exactly, very good. All right. Very good. Okay. Yeah, force can change the direction, change the speed, change the size, change the shape. Okay, very good. Okay, then tension. There is also a force that I have told, that is electrostatic force between two charged particles. Yeah, 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 exactly. Yeah, yeah, that is electrostatic force. Okay. Maybe nuclear force that you apply between, uh, yeah, in rocket, and the force that exists in nuclear reactor, and even in sun surface we have nuclear energy, and the force is there, that is nuclear force. All these are the example of different forces. Okay, all right. Okay, then we have this topic, that is everyday action, where we apply force. You can just go through this, and it's so easy to understand where do we use these forces in our everyday life. Where do we use these forces? Can you tell me? Okay, exactly. Okay, okay. These are different examples I have presented. You can just go through this. While walking, there is a force known as frictional force. That is why you are able to walk there. While opening any box or any drawers, you are either pushing it or pulling it. While you are opening door, you are pulling it or pushing it. There is obviously a force. While moving any object, you are applying force. You are kicking football, obviously you are applying force. You are squeezing lemon, you are obviously applying a force. Then you are doing any stretching work, or you are stretching a spring, you are applying force. Turning on or turning off the switch, you are applying force. You are pressing something, you are applying force. You are just pressing a nail there, you are applying force. You are twisting something, you are twisting your cloths, you are applying force. You are bending your body or bending something, you are applying force. In all these scenario, you are applying force. And this is a real life everyday action where we apply force actually. Then what are the effect of force? I have already told that it can change the state of body, it can just change the shape and size of body, it can change the direction of body, it can change the speed of body. I have already told that. Then there is type of force, balanced and unbalanced. Right now here in the room I'm sitting, and there are pillars which has balanced force. That is why this room exists. Unbalanced force are that lead to the motion. The net effect is not zero, then you call it unbalanced. Building is there, and building is stationary because the upward and downward force balance each other. And there is horizontal direction force applied, there is opposite applied force known as frictional force. In vertical direction, you have this condition that you can see. Here you have applied force. In opposite direction, there is frictional force. And in downward direction, there is weight. In upward direction, there is reaction force. I have presented four kind of force here that you can see. Then we have overall condition, all of them become zero. Then I have some question for you. If it is balanced condition and you figure out that it is 4 Newton and it is 7 Newton, and where does it move? In forward or in backward? Which direction will it move? If it is 4 Newton, you call it plus 4. 7 Newton, you call it minus 7. The reaction force is going to be F1 plus F2, that is minus 3 Newton. In this way, we can figure out the answer as well. Object is moving toward left, we can just answer that object is moving toward left. In this direction, object will move. In this way, such questions can be framed. It's so easy to understand all these things. Okay. Is it okay, Sanket? Yeah, you just we will further cover these questions in next class as well. You don't worry. I have just started with the topic. Then we have laws of motion. There are actually Newton's first law that tells us that if object is moving, it will keep on moving. If it is in rest, it will keep on in rest position unless you apply an external force. It is the first law. I will explain in next class. Then we have inertia. I will explain it in detail in next class. Then we have momentum, and we have second law of motion that tells that force is equal to rate of change of momentum. Then we have third law that tells us for every action there is equal and opposite reaction. I will explain it in detail in next class. I'm ending the session for today. All right, bye bye, take care.